I'm going to talk about something a little different. I do have the word AI on my slides, but it only appears once just because it's illegal to not include AI on slides these days. But my talk's about something else. It's about thinking about architectures for observability from a data perspective, something that is very interesting to me. I'm Gian Merlino. I'm a CTO and co-founder at Imply. We're a data company. We build a database. It's all based on open source Apache Druid. I started my career at Yahoo doing what, when I joined in the 2000s, they were just doing a rebrand of the team I was joining from sysadmin to production engineering. Now it's all called site reliability, but I think it's all the same stuff. It's all about keeping the lights on and knowing what's happening. At the time, data architectures was a major issue. That still is a major issue. I jumped over from production engineering to building databases, real-time analytics, and now I'm interested in talking about why I'm now coming back to the observability world. So a bit about the company that I started 10 years ago. We're a Series D company. Like I mentioned, we're based on open source software, Apache Druid. It's a real-time distributed database. We are got plenty of funding from some cool investors that we appreciate their support. And for a long time, our only product, our one product was based on Druid, was a real-time analytics product with a cloud offering and an on-prem offering. Our cloud offering processing trillions of data rows per year into the petabyte range, targeting super fast queries. So this is all for stuff like Netflix, Spotify, Apple want to power analytic experiences for their customers that are super, super fast. And the reason that we're now 10 years in coming to observability for our second product that we just launched is because of the issues that we're seeing. And we think that there's something that those of us in the analytics and data warehousing world can offer to the observability world. And we can marry what we've learned with what has been learned in the observability world. Some of the issues in observability: costs are super high. We're customers of a animal-based observability cloud system that is one of our biggest line items right after Amazon. Having lots of tools. We don't do everything through we have our one vendor that is our number two vendor in terms of spend, but we don't do everything through them. We have to figure out all right, is it in this product? Is it in Prometheus? Is it in our internal system? We have different systems for different applications. And this is not great. You don't want to have that. It creates a lot of challenges in figuring out, okay, logs from staging are in this system, the logs from production are in this system, and the logs are here, but the metrics are here because this system was good for logs, this system was good for metrics, and it all sucks. And why is it like this? Our theory is that it's like this because in the observability world, stacks and products are too tightly coupled. So if you think about things in terms of the collection layer, so that's stuff like the agents that live on the systems, forwarders, collectors, that kind of thing. That's what actually instruments everything you want to observe. Then you have a data layer where the data goes to live, and that might be a data lake in S3. If you're using Datadog or Splunk, it's going to be something proprietary. You might be Prometheus. And then you have an interaction layer that's built on top of the data layer. That's what you actually interact with. That's a UI, it's API, it's alerting, it's AI integration even. In a lot of situations, you're getting all of these from the same company, and they're not good at everything. And so some of their products are great, some are not great. You can't use Elastic's visualization system. You can't use Kibana with data stored in Datadog, for example. You can't use the Datadog alerting system with data stored in Elasticsearch. So they don't really work together. The collection layer has been opening up. OpenTelemetry has been great there. So it is now becoming possible to have instrumentation system that is becoming truly vendor agnostic. And my belief is that the next thing that needs to be like that is the data layer. If you'll allow me, I'm going to talk about something similar that happened in the analytics world, in the business intelligence world, that I think is due to happen in observability. So in the olden times, in the 1970s, the very first applications for computers in business, some of the very first was decision support, ERP systems, CRM systems. This was some of the very first things people did with computers in business. And they were, of course, provided by the same company. You'd go to IBM, you'd buy one of their mainframes, and their mainframe, you'd put the data in there, you'd use it to do the analysis, it would do everything. It's a very small market, but it's the fact that this was the first thing that happened in the business world. It tells you something. It's a problem that really needs solving. It's a problem that's very amenable to being solved with computers. The next thing that started to happen is you started seeing applications really designed for specific business needs. So rather than having just a data warehouse or database that you're querying, you're seeing packaged ERP software, you're seeing packaged CRM software. And some new companies come out to do that. And some of them are even focusing on that. You still see a lot of vertical integration. JD Edwards does everything, Siebel does everything. But you companies like MicroStrategy that's really focusing on, at the time, not Bitcoin, but this is in the ancient times. At the time, focusing on the application layer, and their application would actually work on different databases. Going into the 90s, things really started to specialize. You see a ton of new companies coming out that are very focused on the interaction layer, on the visualization layer, on modeling business data. And then you see companies that are very focused on the data layer. SQL Server from Microsoft, they don't care what data you put in there. You have SQL tables, you have SQL queries. They don't think about things like employee ID or whatever. They just think about integer, string, that kind of thing. This is starting to decouple in a big way across the market of visualization from data. And it really powers the growth of the market because now folks are able to select what they feel is the best interaction system for their job and then run it on top of a standard data layer that they're standardizing across their entire enterprise. Things get even more complicated once people start realizing they can decouple that. They're also decoupling the systems to get data into things. So this is the emergence of the equivalent of the collection layers, the instrumentation that we have in observability, agents and collectors and forwarders. In business intelligence, they call it ETL, but it's just the same idea. You ought to instrument things and get data from one place to another. We see the emergence of massively parallel processing. So the emergence of data layers that are now becoming not just single machines or mainframes, but are becoming clusters of machines. Teradata pioneered that, or didn't pioneer it, but they were one of the earlier ones to do that. Moving further into the 2010s, this is around the time that I jumped over from production engineering into the analytics world. So this is the world that when I started in analytics, it looked like this. You have companies that are very massively successful, Tableau, Looker, multi-billion-dollar companies focusing purely on the interaction layer. You have databases that are now cloud native. Things are being rebuilt for the cloud. This is when Snowflake comes on the scene, Redshift, BigQuery. So you see data layers that are taking advantage of cloud-specific features like containerization, like auto-scaling, companies really investing in those data layers, making them as good as possible. And then you see the emergence of these cloud platforms where each cloud platform has first-party offerings. So if, for AWS, you can use Redshift. For Google, they have Looker as a first-party UI. They have BigQuery as a first-party data layer, but you don't have to use everything from the same vendor. Because of this history in the business intelligence world where the systems are decoupled, I can use Tableau with BigQuery. I don't have to use Looker. I can use Looker. They bought Looker. I can use Looker with Snowflake. So things are all interoperable, as is the tradition in the industry. And this is incredibly valuable for customers. It's incredibly valuable for users because you get to use the best tool for the job and you get to simplify your life by focusing all your efforts on managing one data layer, ensuring the data quality there is good, ensuring the cost is good, all this stuff. So this is what powers the BI market to be a multi-dozens of billions of dollar market and growing. Today, it continues to evolve. Really, for databases, the big ones now are all cloud native. The ones that aren't cloud native have dropped off the scene. There's new stuff like Databricks that's based on Apache Spark, and a new suite of ETL systems that's also cloud native. So this separation of these layers has enabled rapid growth of the market and also a really powerful sets of technologies. So what we're hoping to do is help kickstart this happening in observability. It's already started to happen. Raise your hand if you're using a data lake to store any observability data that you can query with SQL. So if people are doing that, that's the beginnings of this. The beginnings of this is some people are starting to move from, I'm going to get off Elasticsearch, I'm going to store my stuff in an Iceberg data lake, I'm going to query it with SQL. And there's a lot of reasons for that. The reason is because those data layers are great. They're very low cost. They're very optimized. They can auto scale. They're very powerful. Those data layers are built by organizations and by teams that are really focusing on building the best data layer possible. But they're generally not focused on building one for observability. Everybody that's building these data layers in their mind has business intelligence in mind. So they all speak SQL. in terms of modeling data, they model data with this sort of standard SQL data types, string, integer, so forth. And it's not always 100% natural to store log data, metric data, trace data. You can do it, but it's not always 100% natural. So what we're hoping to do is keep pushing the industry along, take the technology that underpins the analytic systems, that underpins the business intelligence SQL data layers, but specialize it for observability and really make something that is really marrying the two ideas. And I want to talk about how we're thinking about that and how we think we can help. Like I mentioned, we are really focused on the data layer. We have a UI, but it's like we debated if we should even build one as part of our product. And we eventually decided to, and we think of it as, yeah, when you get your data in, you might want to go just make sure it's there. And so you want to be able to see that your data actually got loaded, but it's not meant to be used for real purposes. It's a sandbox. For real purposes, we want people to use UIs that were designed by teams that are dedicated to building interaction layers for observability. We also don't really focus on the telemetry and instrumentation side. So we plug into the open agent ecosystem that has already started to emerge with open telemetry. What this is good for, a lot of the initial use cases that we're seeing for this platform are cloud native data sets like VPC flow logs, web application firewall logs, DNS logs, like logs that are very high volume, relatively low value per log, but you do want to have them. These are the kinds of things that we've seen people, when they have a data lake for observability project, they may start it with DNS logs, they may start it with VPC flow logs. And we think that an observability specialized data layer is going to be better fit for that. A really huge thing that we're doing is wanting to plug into the interaction layers that exist in the observability world. So I mentioned that in the BI world, everything works with everything. I can use Looker from Google with Redshift from Amazon. I can use Tableau with BigQuery. And the reason that works is SQL. SQL is the common language across business intelligence. SQL is used in observability, but it's not particularly popular. There's a kind of explosion of various languages. You have SQL, you have Splunk's SPL language, you have Elastic's language, LogQL, PromQL. There's a variety of languages. And so what we're doing is we are supporting these languages. So we have a much LLVM has front ends for various languages. They all compile down to an intermediate representation that then gets turned into assembly. We're doing something like that on the data processing side. So we have an intermediate language that is what we actually execute in our data layer, and SQL compiles down to that, but so does Splunk SPL, so does LogQL, so does PromQL. And this is what enables being able to use this data layer with tools that already exist as opposed to just a new set of tools. And then I have the word AI here, but I'm not going to talk about that. Do AI stuff, there's AI plugins. Love it, love AI. So what's the point of this? The point of this is to solve the same kinds of problems people were solving with the decoupling of data from interaction in business intelligence, making it easier to manage sprawling data sets, having them all organized and cataloged in one place, and having it be much easier to control costs and control complexity when you can store things in one place. And what makes that possible is being able to use that data in a variety of ways and not just the one way that the vendor makes possible. So this is a world that we think observability will get to and must get to. It's inevitable, I believe. It happened in business intelligence and unlocked massive value for customers. I think that value is latent there in the observability space. And we're hoping to be part of making that happen. As part of focusing on the data layer, what that enables us to do is really focus on making a good data layer, because we can't rely on the value of our applications because we don't have applications. So we can't just say our data layer can be all right because we've got a really killer dashboarding tool and the customers are locked in because they built like 100 dashboards and they're not going to migrate them. Vendors do think that way. We can't think that way. We don't have a dashboarding tool. So the data layer has to be really good. And so we're focusing on efficiency for storage. We're focusing on query performance. Like I mentioned, the standard SQL data layers, you model your data as string, integer. Some of them have a map type. We've introduced observability specific types to our data layer. There's a log type. And what makes a log type special is it's not just a log string, it's a string and it's fields, because you always have your message and you have your attributes. And the compression takes advantage of both the string and the fields. It understands JSON natively. So if you have JSON, we compress it a special way. It understands log format natively. That's compressed a special way. If you have any redundancy between your fields and your message, that's also taken advantage of. If you have multiple messages that follow the same format, which is very common in logging, I'm going to have essentially a template that just the IP changes, that the same message gets logged out 1,000 times. We take advantage of that. So we take advantage of all this log specific compression. And what we get is we have indexes in our system to power wildcard searches, things like that. Even with the indexes, in most cases, our data footprint on disk is smaller than the gzip raw data because gzip doesn't know about logs. Query performance is also very good. This is linked to the compression. Generally, the better you can compress data, the better it can perform. There's less data to transfer around. I mentioned that the savings we get from having log-aware compression are so significant that it allows us to add indexes and still be under our budget of footprint. And so we use those to have queries be really fast. So we've done a lot of internal benchmarks versus various observability tools out there, like the ones that I mentioned. And we tend to be in the 3 to 10x faster range for the benchmarks we looked at. A lot of that, like I said, is due to just the data being smaller, having less to transfer around. An example architecture, how we work with Splunk. I picked Splunk as one of the first ones that we shipped. It's an interesting integration that I am highlighting here because of how it works, and I think it's cool. So how many of you here use Splunk? Cool. So a few of you. So in Splunk, there's forwarders and agents that instrument the stuff that you are observing. There's Splunk indexers that are data servers that receive data from the forwarders and index it locally, handle queries. And then there's what they call a search head, which receives queries from the user, from the application, forwards them to the indexers where some of the operations are pushed down, and the search head finishes up the query and sends the result back. In Splunk, there's a feature called federated search, and we integrate through that feature. The way federated search works in Splunk is the search head can actually query not just its indexers from its own cluster, but it can query a remote search head from another cluster. So this is used, for example, if you have Splunk Cloud and you want Splunk Cloud to access your on-prem Splunk installation, you can set up a federation from cloud to on-prem. It's also used if you have Splunk installations in data centers throughout the world, and you want to have one central location you query them all from. You can federate that way. So we hook into the system. We speak Splunk's query language, SPL. We receive queries just as we would if we were a federated provider. And we speak their queries and their protocol, and we integrate that way. And this is generally our strategy for integrating with things. This is also how we integrate with Grafana. We speak the Loki protocol, and we run logql queries just like Loki would. And we do this because the alternative is crappy. The alternative is extracting data into another tool. It's not going to perform very well. So we always go native with our integrations. In Splunk, the setup is pretty simple because federated search is a built-in feature. You're just putting in a host name, putting in a username and a password, clicking OK. It's a few buttons, and then it works. The setup in Grafana is very similar. And on the user side, you're just adding this word federated to your search. So the index in Splunk is like a table name in a database. And so you add the word federated in front of it, and then it goes to us instead of to the local Splunk system. The Grafana integration is similar. You would connect to you tell you're connecting to a Loki instance, and you provided our Loki compatible endpoint. And then any queries you do to that particular Loki connection are going to us instead of a real Loki. So I guess in conclusion, I'm excited personally to come back to the observability world after taking a detour in analytics for the last 10 years. And I think that I've seen a lot on both sides of the coin. And I think that these worlds have a lot to teach each other. I think that the analytics world models data in a way that's a bit too simplistic, doesn't really appreciate the richness of observability data types. In the observability world, there's still this, what looks to us in the analytics world as a very old-timey way of looking at things where you get everything from the same vendor. And I think combining these two things must happen at some point, and we're trying to make it happen. We're trying to push it along. Thanks for coming. Any questions? Yes.
Yeah, if you could just wait a second, give you a microphone.
Thank you. So my first question is, so your company just focusing on the data layer, right? So the thing is that then, for example, we as a customer, we have to deal with another point of the failures, right? Because we have agents from the different companies, right? For example, Prometheus or the Loki or whatever agent that we are using for, right? To extracting the data, put in your data layer using the different tools, right? For data visualization, right? Even for the observability, everybody today looking at the end-to-end observability to find the anomaly right away, right? For the auto healing, right? Why should I deal with another point of the failure?
I think the answer is that the reason this evolution happened in the business intelligence world is because in theory, you could have products that are more tightly integrated if they all come from the same company, one place to go for support. And that is something that happens, but it was massively outweighed by the downside, which is if you do get everything from one company, that company has immense negotiating leverage over you. You're paying a lot of money to them. And also, their products are not going to be at the same level of quality. So a company might have a very good dashboarding tool, but a poor alerting tool and a poor anomaly detector. Or they might be great at, they could be great at one thing and bad at another thing. And so what tends to happen is people want to do more with their data is they want to get the best in class version of every way of interacting with their data. And they want to do that without having to store a copy with every vendor.
My second question is, so the infrastructure metrics or the logs or the tracing, they have a different type of the quality of the data. For example, for the log, you have to do the lot of the parsing, right? Pre-parsing or on the fly parsing, right?
Yeah.
What is your solution for that piece? Because you have to slice and dice to make a high quality data, right? In order to use it, right?
Yeah.
For example, whatever data that you're pulling from the Prometheus is already clean,
Yeah.
right? So every field has been defined, you can easily index it, right? But for the logs, because there is no standard way for the companies out there to generate the logs, some of them on the text format, they are not really following any specific type of format. Of you have to do spending lots of the time for just the pre-parsing or on the fly parsing, which is slowing down the entire.
Yeah, absolutely. That's an issue. And that was kind of what I was alluding to when I was talking about needing to appreciate the complexity of observability data, because you can't just model it as, okay, log, string. It doesn't work that way. Our approach to that has been to do as much in the agents as possible. So a lot of the agents do support some interpretation of what's happening with the logs on the agent side. So by the time they come to a collector or a forwarder, they already have some fields extracted. And also to recognize common structured formats. So if you're sending JSON to us, we automatically recognize it as JSON, extract every field, build indexes on those fields. If you send us log format, X equals Y, Z equals A, that thing, we do the same thing. We treat that the same as JSON. And if you're sending just text that you would like to extract something from, but it's not a sort of standard format, then our approach to that is you can define a pipeline. And if you define a pipeline in our system, it's a feature where you can pattern match text and you can say, okay, if it matches this pattern, extract this field. Of course, you can also do that at query time, but if you do it at query time, it's like applying a regex at query time, which is going to be slower and not be able to leverage indexes. And so in general, what we're encouraging folks to do is, sure, if you're sending JSON or log format, or if your agent's already structuring it, it'll work great. If you're wanting to get structure out of unstructured text, then play around with it at query time. If there's structure that you see as common and you want it to be fast to query, then you should set up a pipeline. Yeah, for sure.
Hello. I understand that your idea here is that we should treat this as a separate functionality and have multiple vendors. And I like this idea, but I definitely feel like for a lot of businesses, there's not as much motivation to go into detail in depth for something like platform observability, where business intelligence is more aligned with what is going on about the business. And so my question for you is, have you considered working with any existing observability vendors so that people could have a single SKU that included your technology, but also the front ends that obviously you're not working on trying to do?
Yeah, that's a great question. It's early days for us with this product. We just launched it last month, and we would absolutely love to be doing partnerships like that. One of the reasons that one of our first integrations was with Splunk is because those do tend to be larger customers, more enterprisey, and customers that may be more interested in thinking more about how they're storing their observability data. Our guess was that a lot of the smaller shops may just be like, oh, we're just going to do whatever and not worry about it. But yeah, I think that we'd absolutely love to do partnerships like that, and hopefully we'll be able to announce some.
All right. Any other questions? Going once, going twice. Gone. All right.
Thank you, everybody.
Thank you very much.